Basically, the video today is an intersection of two series of videos. The first series is one I've just been doing, 165 through 167, which is serializing and deserializing a data structure in memory to a disk file, to and from a disk file. And the other series is 144 and 146, which is a binary read and write of various data types to a disk file. And as you might suspect, the intersection of these two is basically a binary read and write of a data structure to a disk file. So rather than writing individual data items like int or string by themselves, we're writing structures and reading structures. And the secret behind this is a data class, or a class called BinaryWriter, and a method called BinaryWrite. The difference between BinaryWriter and BinaryReader, which we'll be looking at in the next video, and serialization and deserialization, is that serialization is like an automatic transmission. Basically, serialization is just one method call when you get right down to it, and it writes an entire collection of data records out to a file, and just one other method that reads an entire collection of data records into memory from a data file. So that's like the automatic transmission. It does everything for you. With BinaryWriter and in the next video BinaryReader, it's like a stick shift in that we have to do everything ourselves. We have to write each field out individually ourselves, and in the case of reader especially, be aware of what the data type is of each field, because in effect we're marshalling the data ourselves. Now, the form we're using is essentially identical to what we used in the last 3 videos. We have a series of 4 fields that we fill in as the user, say of a school administrator, filling in student information, and then we say save student info. And basically when we press this button, we're not saving it to a file, we're saving it to memory. So we have a growing collection of records that's in memory each time we press this save student info button, and the number of records will go up as we have more and more records added to this collection. And then by pressing the display student info, we display in this multi-line text box what the collection of records is we have in memory. So both of these just involve memory operations. And then, as before with serialization, the two items that involve writing and reading to a disk file are binary write to file, which previously was serialized to file, and binary read from file, which previously was deserialized from file. So the actual structure of the record is defined as a class. We have public class student info, and then we have the 4 fields that are associated with those 4 input fields, and we fill this in via constructor, where we have int underscore student number, which gets assigned to student number, which is the data member, and so on for each of these 4 items. This has been explained in the previous 3 videos, so I'm not going to go into it in too much detail, but I will say as a global variable at the top of the file, we have the list of type student info called student record, and we allocate this as an empty list. And we also have a global variable called num student records, which corresponds to that text field, which shows the number of records in memory going up. And then on the constant string for student file, which is the disk file we write out to and read in from, I used to have a type of I think SDA or something like that for serialized data, and now I have BDA extension for binary data. And one of the main differences with the serialized data, you have a lot of overhead in the header. You'll notice if you do a hex dump of that file, there's a lot of additional information that gets put in to tell the system what it's serializing and how to deserialize it and so on. Whereas with this, we just write out the binary data. As I say, it's a stick shift approach. We're doing everything ourselves. We write the data fields packed one next to another, read them in from a packed system, and we have to know what the data types are and interpret them correctly. So we're doing the stick shift here, where we have to know everything and do everything ourselves. Well, if we compile and run this program, and I put in some data, say 1 Travis McGee. I've been using the same data so much I don't think I can type anything else in now. And we say save student info. That goes into the memory structure and the number of records gets incremented. And we do the same thing with the second record. And now if we press display student info, in the multi-line text box, it just shows the data that we saved into memory, but it's not written out to a file. However, if we press the binary write to file button, it does write this out to a file, and it pops up a message box that says 2 records, should be records, but it says record, written to binary file. Say OK, and that clears out the text field, because later in the next video we want to look at binary read from file, which if we press that, it reads the 2 records back in. And this also happens at the start of day when the form first loads, so that you can do a bunch of record entries, close the program, then bring it up the next day, and you'll see what you've already typed in, and you can start typing in new data. Well, if we look at how this method actually works, the button for binary write, we have 4 local variables, an int, a string, a date time, and a second int, and 1 student number, student name, date of birth, and average mark. And then I initialize a local variable called nWriteCount to 0 to keep count of the number of records we write out. And then I look at our list of collections, student record, and the count property of that. And if the count property of that is 0, it means we haven't saved anything in memory. So I just pop up a message box that says you need to enter data in memory before you can write it to the binary file and return. Basically, that's a error checking type thing on the level sort of the user and sort of the programmer. And then we use something called a using. And the using is interesting in that it sets up a scope. We have BinaryWriter BWR equals new BinaryWriter, and then we open a file stream with a file.open of the predefined student file name I showed at the top, and a file mode of create, which basically creates the file, and if it exists already, it overwrites it. But the interesting thing about this using is we have a brace here and then a brace down here corresponding to it, and this BWR is a valid variable of BinaryWriter type only between these 2 parents. So as soon as we fall out of this code, it gets disposed, so we don't have to worry about garbage collection. It's kind of a nice approach of doing it. I probably should use using more, but I thought especially for BinaryWriter and binary reader, it's extremely appropriate to use a using and create a scope which disappears when you're done using it. And then we have a for each that basically goes through the student record collection of records and puts in an arrange variable called SI. and then we look at each of the fields in turn, the SI.student number, the SI.student name, SI.date of birth, and SI.average mark, and put those in our local variables. So we're basically going through each record in the collection in turn. And then we do the BWR.write. And the nice thing about the write is it knows the data type, so it knows how big a field to allocate in the binary file. In the case of an integer, you're going to allocate 4 bytes if it's a int 32. And in the case of a string, as the second write is, it writes the length of the string in 1 byte, and then it writes the string. It's a format in the old PDP-11 that used to be called descriptor format, where you have a length followed by the actual characters of the string. So the BWR_write does that for this string. And unfortunately, write interprets a lot of different types of variables. It says here it has 17 overloads. But one type of variable it can interpret is date time. So on the date time variable, we have to do a toShortDate string convert to convert this to a string. So basically on this write, we're writing out a string again. I think it's always going to be an 8-character string. That's the date. And then finally we do another write of another integer. So that'll be another 4 bytes within the file. And then we increment our number of writes. So that basically we do that so when we fall out of this for each loop and the using, we put out a message box that says the count of the number of records we wrote out. And I should probably change this to records. Although if it's only 1, I guess it's right. Maybe I'll put an S like that. And then I clear out the text box field, because when we do a read in, which we do actually when the program first starts, it'll fill in this, and we want it clear for it to be filled in. So if I compile and run this again, the message box pops up that says we read in 2 records, which is the 2 records from what we did previously. And we can see they're shown in the text box. And the number of records is set to 2. So we can keep going. We can add more records. Oops, not EE. I'll actually get an error on the form checking if I'd done that. And we save that and we increment that, and we can display the number again. And if we do a binary write, it's going to overwrite the previous file. It's going to do a file create type method, so it'll overwrite that, and we'll just get the same 3 records all the time. If we do the binary read in, we'll get the 3 records that we put out. So that's basically how the binary write works. And the binary read is actually a little more complicated. It's, you know, don't panic. As Hemingway said, that someone asked a character in his book, how does he handle all these dangerous situations he gets in? And he says, don't get daunted. Whole secret of my success, I never get daunted. So as long as you don't get daunted, you'll be okay. But binary read is slightly more complicated. And we'll look at that in the next video. Well, I hope you enjoyed this video and learned a lot. And I'd appreciate it if you'd subscribe.